The periodic table, the master map of chemistry. Have you ever wondered how scientists organize all the known chemical elements in the universe? Imagine trying to study more than 100 different elements without a proper system. It would be almost impossible. Fortunately, chemistry has one of its greatest achievements, the periodic table. The periodic table is a systematic arrangement of all known chemical elements based on their atomic numbers, electronic configurations, and recurring chemical properties. It serves as a universal reference that allows chemists to predict how elements behave, how they react with one another, and the types of compounds they form. Every square on the periodic table represents a unique element. Each element is identified by its chemical symbol, atomic number, relative atomic mass, and position within the table. Today, the modern periodic table contains 118 confirmed elements, beginning with hydrogen, the lightest element, and ending with oganesson, one of the heaviest known elements. The modern periodic table did not appear overnight. In 1869, the Russian chemist Dmitri Mendeleev arranged the known elements according to increasing atomic mass. More importantly, he noticed repeating patterns in their chemical properties. His remarkable insight allowed him to predict the existence and properties of elements that had not yet been discovered. Later discoveries confirmed his predictions, making the periodic table one of the greatest scientific accomplishments in history. Today, the periodic table is organized according to atomic number, which is the number of protons found in the nucleus of an atom. This arrangement provides a much more accurate representation of the relationships among elements and forms the foundation of modern chemistry. One of the most important features of the periodic table is its organization into periods and groups. The horizontal rows are called periods, and there are 7 periods in the modern periodic table. Elements within the same period possess the same number of occupied electron shells, or energy levels. As you move from left to right across a period, the atomic number increases by 1 with each successive element. This gradual increase changes the electronic structure of the atoms, resulting in predictable changes in their physical and chemical properties. The vertical columns are known as groups, and there are 18 groups in total. Elements within the same group have the same number of valence electrons, which are the electrons in the outermost shell of an atom. Since chemical reactions mainly involve valence electrons, elements belonging to the same group exhibit remarkably similar chemical behavior. For example, Group 1, known as the alkali metals, contains highly reactive metals such as lithium, sodium, and potassium. These elements readily lose 1 electron to form positive ions. Group 17 contains the halogens, including fluorine, chlorine, bromine, and iodine. These are highly reactive nonmetals that readily gain 1 electron during chemical reactions. Group 18 consists of the noble gases, such as helium, neon, and argon. Their outer electron shells are already complete, making them exceptionally stable and largely unreactive under normal conditions. The periodic table also classifies elements into metals, nonmetals, and metalloids based on their physical and chemical properties. Metals occupy the left and central regions of the periodic table. They are generally shiny, good conductors of heat and electricity, malleable, ductile, and possess high melting and boiling points. Most metals lose electrons during chemical reactions, forming positive ions known as cations. Nonmetals are found mainly on the upper right side of the periodic table. Unlike metals, they are generally poor conductors of heat and electricity. Many exist as gases at room temperature, while others are brittle solids. Nonmetals usually gain or share electrons during chemical reactions, allowing them to form stable compounds. Separating metals from nonmetals is a diagonal staircase-like boundary occupied by the metalloids. These fascinating elements possess properties intermediate between metals and nonmetals. Silicon and germanium, for example, are semiconductors and play a crucial role in the manufacture of electronic devices such as computers, smartphones, and solar panels. Understanding these classifications enables chemists to predict how different elements will interact during chemical reactions. One of the greatest strengths of the periodic table is its ability to reveal periodic trends. These are predictable patterns in the properties of elements as you move across periods or down groups. As you move from left to right across a period, the atomic radius generally decreases because the increasing nuclear charge pulls the electrons closer to the nucleus. In contrast, Moving down a group causes the atomic radius to increase because additional electron shells are added, making the atoms larger. Metallic character decreases from left to right across a period, but increases as you move down a group. Electronegativity, which measures an atom's ability to attract shared electrons in a chemical bond, generally increases across a period and decreases down a group. Ionization energy, the energy required to remove an electron from an atom, follows a similar trend. It generally increases across a period because the nucleus holds the electrons more strongly, and decreases down a group due to increasing atomic size. These periodic trends allow chemists to predict the behavior of elements even before conducting laboratory experiments, making the periodic table an incredibly powerful scientific tool. The periodic table is far more than a chart hanging on a classroom wall. It is the foundation upon which modern chemistry is built. Scientists use the periodic table to predict chemical reactions, design new materials, discover medicines, develop fertilizers, manufacture electronic devices, generate clean energy, and explore the composition of distant planets and stars. Nearly every branch of chemistry, biology, medicine, engineering, and environmental science relies on knowledge derived from the periodic table. For students, mastering the periodic table is essential because it provides a framework for understanding chemical bonding, chemical reactions, acids and bases, electrolysis, organic chemistry, and many other important topics. More than 150 years after its creation, the periodic table remains one of humanity's greatest scientific achievements. It continues to guide scientific discovery while helping us understand the building blocks of matter and the remarkable order that exists within the natural world. If you found this lesson helpful, don't forget to like this video, subscribe to the channel, and turn on notifications for more in-depth chemistry lessons designed to make complex scientific concepts simple, engaging, and easy to understand.